Before we start the real talk, I have some questions and a story for you. First question is, and please raise your hands, if you use Docker in your day-to-day business. Who does? Most of you, okay. That's really good. It's an intermediate talk, so I hope that most of you do. The next thing is, who is using another technology like Rocket or something for building containers? Okay, that's not that much, okay. But you may know that there is a difference between Docker and a virtual machine. Who does not know what that difference is? Most of you do, I thought so. So to not annoy the people who already know but still get the information across, I will tell you a little story. Okay, the story is about Mr. Process Guy. And once upon a time, Mr. Process Guy lived in the user land quite happily and did his stuff the user programmed him to do. And he did this on the machine of his developer, or God, as Mr. Process Guy calls the developer. And things were fine, things were good, everyone was happy. But one day, Mr. Process Guy slipped. Maybe there was never an evidence, but maybe because God did an error, a mistake. But it was never proven. But what happened is that this process slipped and died, and in such an horrible, horrible way that the whole computer went down with Mr. Process Guy. And the developer was shocked and thought of an opportunity or a technology to not let this happen again. And he said, okay, when the machine goes down, if I have written bad, if the process guy makes a mistake, then I just need to put a computer in a computer so the inner computer crashes while the outer computer still lives. And it was good, it worked, it was a virtual machine. So with a virtual machine, you're having a computer inside of your computer. I will show this to you technically later still, but okay. So as you can see, here are three little Mr. Process Guys. Why? Because, of course, you need to run more than one program on a computer, stuff like that. So the developer had three processes running, each in its own machine. And over time, it was a large family. And the host system at one point said, oh, wait, I don't have any resources left. And again, horrible things happened. And the developer again thought, well, what can I do to have many Mr. Process Guys, because I like big families, right? I want to have a big family, and still have not crashed the whole computer when one of them is dying. And he invented the Linux namespaces, known to you as Docker. And he isolated Mr. Process Guy. As you can see here, he's still happy, although isolated. Mr. Process Guy likes isolation. And this isolation is what you know as Docker. The thing about that is the process still runs on the hardware of the host. It's not some kind of abstraction layer between that. And you can have multiple guys. You can have a really large family because you do not have the overhead of running a computer on your computer and another computer on your computer. And if some of those process guys are dying, that's no problem because they die in their isolated space. And in most of the cases, or in so few cases that you can use Docker in production, the system is not going to went down. So much for the story. Another thing, what is the goal of this talk? Because I want to set your expectations right. I did this talk at Jena in Germany at an unconference, and people were confused. I guess you're not that easily to confuse, but still, the goal of this talk is to teach you what is the technology that makes Docker live, or that is behind Docker. So it's not that I'm programming a tool with you that you can take home and use in production, because we will program something later. Or I will do that, you will watch, hopefully. But it's to teach you the underlying techniques, okay? It's a teaching talk. It's basically Docker under the hood. So we are opening up Docker and looking inside without using Docker, okay? For those people that don't like stories, this is the thing as a show, how do you call it? Whatever, you see it. We have the infrastructure for both virtual machine and Docker. Then we have some host operating system. And now comes the first difference. When you run a virtual machine on the left side, you have a thing called hypervisor that translates hardware calls, and the Docker daemon runs just on the host operating system as the hypervisor. But then the guest OSs, in this case, are needed in the virtual machine. So this is the part where I said you have multiple computers because you always run a whole operating system. In the case of Docker, you don't. You have some binaries and libraries included in each Docker thingy here and in each guest OS. And on top of that, the applications you want to run. And in the case of Docker, it's jailed. It's isolated. Okay. Questions so far? No. Good. You can ask questions at the end as well, but if you didn't follow through until this point, then you have a problem. Okay. Oh, this was the question slide, sorry. Now, the whole thing I'm talking about is namespaces. Great, isn't it? Yeah, namespaces is the whole thing that I'm talking about. And namespaces is a technology that comes with the Linux kernel. So that means that you have to run some form of Linux to run Docker. For Windows user, that means Microsoft did an effort to create Docker-like or Docker compatibility, but still they have to mimic these Linux namespaces. And there are a few. It's mount. The mount namespace isolates the file access. Oh, there, I've written it down. Great. To a given directory. So the process, again, this is important. The process itself is limited in what it can see on the host system. So the process that we are running in a namespace can only see the files we allow this process to see. Same is for process ID or PID. This limits what other processes can be seen by a process. Then we have the network namespace. The network namespace, surprise, the same for network interfaces. A little bit different is the inter-process communication. Who works with pipes in Linux? Yeah, a few of you, okay. It's basically, it's a technique that allows two processes to communicate to the other process. They can either share memory or use pipes, and it's just a technique that we can limit with that as well. Then we have the Unix time-sharing system. I like that namespace, because the Unix time-sharing system, what could it be? Of course, it's about the host name. I have no idea why it's named that way. Maybe I find out someday. But yeah, it's about host names. It's the UTS namespace. And then we have the user ID that separates the user ID from the other user IDs. And that is the reason, because when you're running a namespace process in Docker, you're root in the container, because your user ID 1. You can change this, but by default. Okay, in this talk we will just focus on these three. Docker uses all of them, but that would be too much, and we only have like 45 minutes. Okay. Now, this was a lot of name dropping, and now we are getting a little bit closer to the explaining part. The plan that we will be executing in a moment is we will create a main program, like really do programming stuff, okay? Then we will create, in this main program, we will create a child process, and then we run this child process in an isolated environment. And that is what Docker does, right? Docker runs a process in isolation. So that means that all the time you're running a container, only one process is started. Of course, this process can spawn other processes in its running time, but initially only one process is started. To do this, we have to do a little bit of stuff, like creating these namespaces, then attaching the namespaces to the child process, and then run it in isolation. Okay. The language I will be using to do this is, who recognizes this? Go. Yeah, Go. It's a Google-made language, or language made by Google, that is statically compiled, yada yada. Maybe I will do a Go talk at the unconference tomorrow, if someone is interested about Go. But the thing why I choose this language is because Docker itself is written in Go. And we can do stuff we couldn't do with PHP, like you will see in a moment. Okay. What do? We have a skeleton program. I will guide you through the program, then make changes to it, so that in the process you can see where these namespaces come into play. You don't have to get everything. If you don't know Go, it's no problem. Who does know Go? Okay, too few. No, it's no problem. Okay, wait. Good. Does this work? Awesome. Yeah, because I'm synchronizing two browser views. Okay, this whole import stuff isn't that important, but what we have here is we have a function called main. And the main function, surprisingly, is the function that is run when you start the program. And when I initially run the program, I want it to be the main program, and then I want to fork a process out of it, and this process will be namespaced. So what I'm doing here is I'm checking if the first argument I'm getting is child. If it's not child, then I'm running the parent function, because obviously I'm the main process. Then what I want to do is I prepend child to the arguments, and then start myself again. So now I have child as process. For technical reasons, I have to present you the code like this. It's commented out, and I will comment it in and explain it. If I do a talk like this again, it will be better. Sorry for that. Okay. In the parent function. So when I initially start my process, what I do is I create a command. This is basically like in PHP, the exec functionality. You just execute a process. It's exec.command. And what I'm executing here is proc self-exec, which is just a pointer to my own executable, conveniently. And then what I'm doing here is, this is a little bit Go-fu. I'm appending, actually I'm prepending because the order is important here. So I'm prepending a string child to the existing arguments OS args. It's like the arg array in PHP. And by starting at the first and not at the 0 indexed parameter, I'm omitting the first because the first parameter, as in PHP, is the file name, and we don't need that. Okay, so what I'm getting here is I'm creating a new command, child, and whatever the user wrote. And what I'm doing then is something that I love Go for. I'm wiring up the OS standard in to the command standard in. So everything the command prints out is printed to the to these, or everything that the underlying command like psaux or ls wants to print out to the OS is catched by the process. Then I have this must cmd run. This is just I'm running the process, and the must function just makes sure that everything is in order. And then we have the child process. And that's relatively easy as well. First, I'm printing something out. Hey, I'm running. So when this appears in the log, we are in the child process. Then again, I'm creating a command, and this time this command is built from the stuff the user gave me. Okay, so the child process here uses in its exec command line uses the OS args. The first one in this case is the second or the third, because first we have the file name, we don't need that. Then we have child, we don't need that. And then we have the user input. And then from the third onwards or the fourth onwards here, we just expanding the arguments. Whatever the user wrote, we take it, no matter what. And we run it on our machine because why not? Okay, so let's do this. One thing. When I execute code, I click on this button, but you can't see my mouse because this is just a mirror of or a second browser view, and I'm clicking in another one. Don't be confused. Okay, so I'm doing maybe an ls, and I execute this code. And what happens is, as you can see here, yeah, basically it's the current directory I'm in. A lot of stuff, and the stuff is obviously from my computer. We can do another thing like ps minus aux, for example. Then we execute the code, and minus aux, something is, okay, just takes some time. And now I have some running processes, and quite a lot, as it's usually the case. Okay, so far for the skeleton, we can run a command by giving our main process some stuff, okay? And it's run in the background. Okay. Now I talked about namespaces, right? And namespaces are the bread and butter of Docker. So this newly spawned process that runs ps-aux, for example, or the ls, has to be namespaced to isolate it. This is the fun part, by the way. Okay. So, and the magic takes exactly 3 lines if you want to write it beautiful. I'll explain. What we have here is another attachment to our command. The command has an attribute, sysproc attribute, somehow like that. And then we have a package. This is a Go package here. I'm not sure if you can see my. Oh yeah, yeah, you can see this. Syscall is just a package that directly communicates with the underlying operating system, so to say. So, and we are having the syscall, sysproc attr, and this just sets attributes on a process I'm about to run. And what we're doing here is the nice part. This, if you take anything away from this talk, basically it's that. This is how namespaces are done. This is how Docker works. I'm just explaining it in a very difficult way. Okay. So we are setting clone flags. Clone flags, why is it clone flags? Because we are cloning ourselves more or less. And we are setting clone new UTS. This was the hostname thingy, you know, the funny naming. New PID, so that our process will getting a new PID and can't see other processes. And then we have new NS. Any idea what new NS may be? Mm-hmm. What does it restrict? Okay. Of course, the file system. What else? No, I know why that is named so obscure, because it was the first namespace ever invented. And the Linux guy said, okay, how do we call this? Just set new NS on a process and we will create a new namespace for the files, and that's it. We will never need another namespace. Well, they did. Okay, so far so good. So now we have new namespaces and everything should be fun. Oh, I just messed up. Yeah, and everything should be fun. In the child, there is nothing we have to change, because here we are just creating in our parent method, we're creating a new process, and we run this as a child. And this child process gets the new attributes. Okay, so far. Oh, wait, I have to show you something, because this is the slide before. Who am I? Just so you know, I am N, short for Nicholas. This is my Linux username, so just so you don't get confused, what is N? But who am I should result in N on my computer. If it's the same on yours, it's a weird coincidence. Okay, execute code. Oh, what happened? Let's have a look. Panic. Fork, exec, proc, self, exec, operation not permitted. And here we are. This is the main thing that makes Docker insecure. To set namespaces on a process, you have to be root. And if you're not root, you are not allowed to run container. This is why in the Docker installation manual it says add yourself to the Docker group and be careful because now you're root. Awesome. Not. But I have prepared a sudo version of my program. I can. It doesn't change here, but here is now go sudo in the middle. And let me clear the lock and execute. And now we're root. Awesome, isn't it? Let's see. I expect now to see only my process. Who else? I want to. Okay. You're wrong. Okay. PS minus AUX, and it's running, and after a couple of time, I see all processes on my computer. That's bad. But I will come to this in a moment. The next thing would be I will execute, hello? Oh, no. I will execute ls minus la, execute. Oh, that's my computer. So we are setting namespaces on the process, but that's not enough. Because by setting namespaces, you are cloning them. So in most cases, in the new namespace, you have the same stuff as in the old namespace because it's not yet restricted. So we have to restrict stuff, okay? And yeah, we have to restrict stuff, okay. First of all, we want to restrict a file system. And actually, we do not restrict it, but we give our child process a new file system. And conveniently, I downloaded the Docker Debian image, extracted it to a location on my computer, and we will be using the Debian Docker image as our root file system. That's why this path I'm revealing here, ta-da, is prefixed with home and documents, talk, and so on, okay? Then we defer an exit function. In case you don't know that, defer just means whatever happens before you exit that function, run this. Then we say, okay, must error just means if there is an error, please panic. And then we do a change directory. So we are change routing into the new or into the prepared folder that I have on my computer with all the Debian stuff in it. And then we have to do a change directory. This is just so the system doesn't get confused, because when I'm running the process in a folder that is non-existent in the new root or in the new file space, then everything is bad. Okay, and just for convenience, I create a new environment variable here, and I'm adding bin and user bin to path. Otherwise, I would have to type /user/bin ps and so on. Okay. So everything should now be set up file-wise, so ls minus la. Then we execute the code, and as you can see, or maybe you remember, this is something different than the thing you just saw before, and I can prove it. Okay? Something is set as h and something else. And as you may notice, here is user 1000, the user ID 1000. And that is because internally now in the new file system, my user ID is not reflected in the passwd. Oh, sorry. A little bit of German here and there. Okay. So far. Let's finish that up by creating our namespaces that are missing. We, again, have to do that in the child. And what I want to do now is I want to add the namespace that gives us our own process list. And we do this by syscall mount. So that means we are mounting proc to proc with a file system proc. Sounds weird, but proc is actually a file type like file system type like FAT32 or NTFS. And when you are running PS on a Linux system, all it does is it reads the proc directory, and every process has an entry there. That's it. So we are mounting our file system here, that is the proc file system, and we defer an unmount so my system doesn't stick forever with the container or container. Had that problem before I discovered that I should unmount this. The process just persisted forever. was awesome. Okay. So now when I do a ps -aux and execute that code, wow, mission achieved. So we have isolation process-wise. Let's have a look again at the file system. Enter doesn't work. That's isolated, and again, when I'm calling who am I and execute that code, I'm still root. Now, this behavior I just showed you is basically the whole thing that is to Docker. Yeah. From that, there are a couple of consequences. One of them being, when you're running deliberately more than one process in a Docker container, you're doing something wrong, or you should have a good reason for doing it. For example, when you have a web server in your Docker container and you're running a MySQL server and an SSH server and an X server because you need Phi and C as well, then you're building your own virtual machine. In a sense, it's about one process. And of course, this is like database normalization to the 5th level. Nobody does that. But you should try and only have one process per container, because that's the thing. Container should isolate one process. There are some use cases where it's useful to have more than one process. The SSH thingy. For example, there was a company that had a lot of virtual machines formerly, and what they did is they connected to them via SSH, did some commands, and disconnected. And then they moved to Docker. So it was relatively easy to switch the virtual machines for Docker images or containers, because this was just, I don't know, web server or something, I don't remember. But the whole infrastructure or the whole programming stuff that connected to these containers, now containers, was still expecting to have an SSH connection. So it was much easier to just use the existing infrastructure and connect via SSH. So that would be a valid use case in my world. Okay. Last but not least, images. Because although we are, of course, not talking about Docker here, this is the second thing that makes Docker great, the thing called images. And what you're doing here, as you know, I have just put some files on my file system and called it a day. I can run commands in this isolated namespace, but I can't give it to you that easily. And what Docker does is it has this layered file system where you create a file system via a Docker file, and then you can give it to someone else, which is awesome, because in this Docker file is also noted down what process to run with what parameters, for example. So awesome there. And the layered file system, again, makes it easy, because when you have your Docker file, who wrote a Docker file already? Most of you, great. Who likes a structured Docker file and makes a run statement whenever there is something different, like I install this, then new run statement, I install this? Who does that? Okay. And all of the others are trying to keep everything in one run statement, right? Who tries to only have one run statement? Okay, and the others don't know what I'm talking about. Great. Okay, now why you should do this is because for every run statement, what Docker does is it runs a container with your current file system, does the changes in your run, whatever, and creates a new file system on top of the other. So this is the layer thing. So when you do things like run apt-get install something, and in the next run statement you would delete the var apt list cache thingy, then it would still be persistent in your Docker image, because in the first layer it's there and you can't change the first layer. So this is one thing, and with each run statement you create a new layer, and a Docker image can only have 300 layers max, so keep it short so others can extend your images. But still, yeah, these Docker images are in my opinion, one of the most, or one of the biggest things that are responsible for the success of Docker, because it's so easy to just give someone a Docker image, because the technology, as we have just seen, is just Linux kernel stuff and nothing else. Okay, the complete code is available here, bit.ly Docker without Docker, or if you are a photograph guy, then just use this. I'm not sure if I managed to put the slides up because of the code thingy, but I'll try. It's on my Twitter account that's noted down on the left. Right. Now we have some time for questions. Actually, we have 10 minutes left, and in case you want to ask me something and you're too shy or don't feel like it, I have Twitter, as I already said, and I would love if you could provide feedback for me at joined in, preferably constructive feedback, since this was my first talk ever. So it would be great to get some feedback. I did some talks at unconferences, but never with a paying audience. Okay, there's a question. Yes?
What is your technique then to minimize the run?
Okay, what is my technique to minimize run? Well, basically what I do is I write my Docker file with multiple run statements, and then I scram everything together in one when I'm done. This may not always be possible, because you may have to run something, do something else, and then run something else. In this case, you have no choice but to make two runs. But when you have yourself, you should always try to condense it as much as possible. It's not always possible, of course. Another thing for small Docker files, I just remembered, is Docker has a build stage in the newer versions where you have one Docker file definition, and the first, basically you write from whatever, do your whole build, and then you have another from, and can use artifacts from the previous build. So if you have, for example, a web application in PHP, but you have to compile Sass or what's the other thing? Less. Something like that, then you can do this in your build stage, and the resulting image is much smaller and doesn't have that much run statements. It's a build stage. Okay, any other questions? Go on.
What do you do to link all the processes together? I use systemd.
Systemd.
I need a hierarchy of all the containers for images that I need. So I use systemd to start the processes.
Okay, so
Instead of Docker Compose.
yeah, what am I using to, just to repeat your question, what am I using to start the different Docker containers and link them together? It depends. When I'm developing on my local machine, I'm using Docker Compose because it's convenient. In production, Kubernetes. But that's more like an orchestration. And Docker files are, again, easy to give to someone else. And with the recent versions, you have a very fine control over what's happening in your Docker files. So if you don't use Docker Compose and you didn't look into it yet, it is...
No, I did.
You did?
I need really a hierarchy of, I mean, one container really needs stuff from the previous.
Oh, you can do this with, so when you need to start one container before the other. I'm using actually wait scripts, and Supervisor D can do this as well, as when I'm correct. I'm not sure you know that. Yeah, you don't know that, okay. He's a colleague of mine. I'm not asking random people. Okay, so that you can do this with wait scripts. So you have already a health check in the Docker Compose, so you can do just ping the other container. But in case of MySQL, for example, if you want to make sure that MySQL is there, you can use a wait script that periodically checks for the other container and runs when the other container is up. So just look up Docker wait script and you will be fine. Yes?
Functionality you just described, is this something you should put in the entry point file?
Yes, that's a good question. Where do I put this wait script? There are two things, the entry script and the command. The entry script is basically run when the container is starting up, and the command is the thing the user can override by putting something on the end of Docker run. That is the default command that is run, so you would put it in the entry point. So that checks for the other container, and then it just runs the command afterwards.
Check could be anything.
Excuse me?
The check itself could be anything.
The check itself could be anything. It's basically just a bash script that does stuff. Yeah. Okay. Anything else? Then thank you.